Welcome to Solar Age, the podcast that shines a light on the path to a brighter, more sustainable future. Join us as we explore the transformative power of technology in creating a Solarpunk world.
Welcome back to Solar Age. You know, we'd love to explore those clean disruptions that'll bring us closer to a Solarpunk future, and today we're taking a deep dive into perovskite solar cells.
Oh, this is a good one.
It's a fascinating topic.
Really fascinating.
Because we're talking about solar cells that could be cheaper, more efficient, and much easier to produce than those silicon panels we're all used to.
Right now, yeah.
So imagine a world where solar panels are like newspapers.
Totally.
Just everywhere, integrated into our life, powering everything.
It's a powerful vision, and I think perovskite technology could make that possible. But to understand why it's such a big deal, we need to kind of look at silicon first. Like, why do we even need an alternative?
Right. Let's unpack that silicon situation.
Okay.
Silicon solar cells have been around for a while. They've been the workhorse of the solar industry, but they do have their limitations.
They're only about 20 to 25% efficient at converting sunlight to electricity. So not ideal. And then the production process, oh my gosh, it uses so much energy mining and purification at over 1,000 degrees Celsius. So not exactly what we think of when we think of Solarpunk, you know, that sustainable future.
Not quite. Especially when we imagine a future where everyone has access to clean energy. So where does perovskite fit into all of this?
Well, perovskite has this really unique crystal structure. It's like this, it's got this formula ABX3. And the A, B, and X, those can be all sorts of different elements or molecules. So it's like...
So it's customizable?
It's totally customizable. It's like a solar cell with a recipe that you can tweak.
Wow.
And that's what makes it so exciting. We can tailor make it for all different environments and purposes. Imagine solar panels for cloudy climates or even integrated into building materials.
Oh, that's incredible. It's like we have a solar toolbox.
Exactly.
And we can just pick and choose what we need for the job. That's amazing.
Yeah.
I remember seeing a video where they basically whipped up a perovskite cell in a lab. Is that a real thing?
Oh yeah, absolutely. Remember that video? It was super simple. They just mixed some materials together and then they did this thing called spin coating just to spread it out, and then they heated it up a little bit. That's it.
Wow.
Compare that to the silicon process and it's like night and day.
Really highlights that Solarpunk idea of working with nature instead of against it.
Absolutely. And it's not just about the lab scale production. Either perovskite can be printed or evaporated, which is amazing for mass production. And that, of course, brings the cost down significantly.
So we're talking solar panels rolling off assembly lines like newspapers.
Exactly.
I love it. Now, speaking of efficiency, I've heard that perovskite might actually be even more efficient than silicon at converting sunlight. How is that even possible?
Okay, so perovskite cells are pretty good on their own, but they really shine when you combine them with silicon, and this is what we call a tandem cell configuration.
Tandem cells. Okay, I've heard that term before, but break it down for me.
Okay, so picture this. You have like a double-decker solar sandwich, right? The top layer is perovskite, which is amazing at capturing visible light. The bottom layer is silicon, which is great at capturing infrared light that goes to the perovskite. So it's like...
They work together.
They work together. It's like a 1-2 punch.
Wow. So you're harnessing like almost all of the sunlight?
As much as possible, yeah. And we're talking about efficiencies potentially over 30%. So almost 50% more than a standard silicon cell.
That's incredible. It sounds almost too good to be true. Are there any downsides we should know about?
Well, no technology is perfect, right? One of the biggest challenges for perovskite is stability. It's kind of a delicate material.
Okay, so what do you mean, like it breaks down easily?
Yeah, things like moisture, heat, oxygen, UV light, they can all cause it to degrade, and of course that reduces its performance. And if you think about it, if we have these super efficient solar panels, but they only last a couple of years.
Yeah, that's not sustainable.
Not at all.
And we want that Solarpunk future where things are built to last. So are scientists working on this problem?
They're working really hard on ways to encapsulate the perovskite layer so that it's protected from the elements, kind of like giving it a little greenhouse to live in.
I like that analogy. You know, in that video we watched, companies like Q-Cells and Oxford PV.
Yeah.
They seem pretty confident that they can get these perovskite cells to last 25 to 30 years, like traditional silicon panels.
Yeah, they are making some pretty impressive strides, but we have to remember that long-term outdoor testing is still very limited. It's still early days.
Yeah.
We need to see how these encapsulated cells do in the real world over many years before we can say for sure that the stability issue is solved.
Yeah, I think that's a good point. You know, we have to be cautiously optimistic. Solarpunk is about hope and a positive future, But we also have to be realistic and make sure these technologies can actually deliver what they promise in the long run.
Exactly. And of course, we have to think about the economic side of things too. For perovskite to be a real game changer, it has to be cost competitive with silicon.
Right, because even if it's super efficient, if it's too expensive, no one's going to use it.
Exactly. Silicon panels right now cost about 12.7 US cents per watt. So for perovskite to be disruptive, it has to get down to that price point or even lower.
Okay, so that's the target.
Yeah.
But haven't silicon prices been going down for years? Can perovskite even catch up?
That's a good question. And yes, silicon prices have been dropping, which is great news for solar in general. But what's interesting is that now the cost of the panel itself is becoming less important in the overall cost of going solar.
Okay.
Things like grid connection fees, land permits, installation labor, those are actually becoming the bigger expenses now.
So it's not just about the sticker price of the panel anymore.
Not anymore. It's about the whole ecosystem around solar energy.
Right. But even so, a cheaper and more efficient panel would still be a huge advantage.
Right.
Especially if we want to make solar accessible to everyone, which is a big part of the Solarpunk vision.
Oh, absolutely. And that's why companies like Q-Cells and Oxford PV are working so hard to bring perovskite to market. They believe that the combination of lower production costs and higher efficiency will make it a winning formula, not just for them, but for the planet.
It's a pretty exciting race to watch.
It is.
But as you said earlier, real-world testing is crucial.
Absolutely.
We need to see those promised efficiencies and lifespans hold up in the real world over many years.
Exactly as Carolyn Ulbrich said in that video. It's really hard to say about these samples that we have out here after 1 year that they're going to last for 25 years. We need more data, more evidence before we can confidently say perovskite is here to stay.
Right. It's a reminder that scientific progress takes time, even with these amazing technologies. But even with those caveats, the potential of perovskite is undeniable. I mean, it has the power to completely transform the solar industry and get us to a clean energy future faster.
And for us solar punks, that's a vision worth fighting for.
Absolutely.
And it's not just about replacing our current energy sources either. You know, perovskite, it gives us a chance to rethink how we use energy, how we design our cities, how we live on this planet.
Yeah, it's like a whole new way of thinking about energy and sustainability.
Yeah, absolutely. And speaking of possibilities, there's one area of perovskite research I wanted to mention that might surprise you.
Okay, I'm intrigued. Lay it on me.
Transparent and flexible solar cells.
Wait, hold on. Transparent and flexible?
Yeah.
What are we talking about here? Like windows that generate electricity?
Exactly. That's one of the most exciting potential applications for transparent perovskite solar cells.
So you're telling me my whole house could be a solar panel someday?
It's not. Science fiction scientists are actually developing perovskite materials that are transparent and flexible enough to be put into windows, building facades, even electronic devices.
So every surface becomes a potential source of clean energy.
Exactly. It's like turning our entire world into a solar power plant.
That is a powerful image, and it really aligns with that Solarpunk vision of a world where energy is abundant and integrated into everything we do.
It really does, and it's not just limited to buildings either. Imagine wearable technology with transparent perovskite cells built right into the fabric, or even medical implants powered by the sun.
Wow, that's incredible. It sounds like something straight out of a Solarpunk novel.
It really does, but we have to remember that even with all of these exciting possibilities, perovskite technology, it's still in its early stages.
Right, right. We've talked about the need for more long-term testing and real-world data before we can say for sure that it's going to live up to all the hype.
Absolutely. But even with those caveats, the potential for perovskite to revolutionize solar energy and accelerate our transition to a more sustainable future is undeniable. I mean, it's a game changer.
It is, and it's exciting to think about all the ways it could be used to create a more equitable and sustainable world. You know, we were talking earlier about making sure that everyone has access to clean energy.
Right.
And perovskite, with its potential for low-cost production and versatility, it could really be a key technology in making that happen.
Absolutely. And it's not just about the technology itself. It's about how we use it, how we integrate it into our lives in a way that benefits everyone and the planet as a whole.
Right. It's about that Solarpunk spirit of collaboration and using technology to create a better future for all.
Exactly. Now, while perovskite has come a long way, there are still some hurdles to overcome before it becomes a mainstream technology.
Like what?
One of the biggest challenges is scaling up production. I mean, making a perovskite solar cell in a lab is one thing, but being able to mass produce them in a cost-effective way, That's a whole other challenge.
Yeah, it's like the difference between baking a cake at home and running a commercial bakery, right?
Exactly. Scientists and engineers are working on different techniques to try to streamline the production process, including something called roll-to-roll printing.
Roll-to-roll printing. I've never heard of that. What is it?
So picture this. You have a big roll of flexible material like a substrate, and it's fed through a printer that lays down the perovskite material layer by layer, and it creates this long sheet of solar cells.
Yeah.
It's kind of like printing a newspaper, but instead of news, we're printing clean energy.
Wow, that is such a cool image. And it sounds so much more efficient and scalable than the way that traditional silicon solar cells are made.
Absolutely. It has the potential to really revolutionize solar manufacturing.
This is incredible. It's like every time we talk about perovskite, we uncover a new layer of potential and possibility.
It really is. And it's not just about the technology. It's about the vision. It represents, a vision of a future where clean energy is abundant, accessible, and integrated into every aspect of our lives. That's the Solarpunk dream.
And perovskite could be a key part of making that dream a reality.
It definitely could, but of course we have to be mindful of the challenges and make sure that as this technology develops, it's done in a way that benefits everyone and the planet.
Right, we need to approach it with that Solarpunk mindset of sustainability, equity, and collaboration.
Exactly. And speaking of collaboration, one thing that's really important is engaging with the broader community, getting people excited about perovskite and its potential, talking about the possibilities, the challenges, the ethical considerations.
Right, it's not just about the scientists and engineers, it's about everyone coming together to shape the future of this technology and make sure that it's used in a way that aligns with our values.
Exactly. We need to have these conversations now so that as perovskite becomes more widely available, we're prepared to use it responsibly and effectively.
And that's where our Solarpunk community comes in, right? We're not just passive observers, we're active participants in shaping the future.
Absolutely. And we have so much to contribute, our creativity, our passion, our commitment to a better world.
So what can we do as individuals and as a community to help support the development and adoption of perovskite technology in a way that aligns with our Solarpunk values?
Well, for starters, stay informed. The field of perovskite research is constantly evolving, so make sure you're keeping up with the latest developments. There's some great resources available online, and we'll be sure to share some links in the show notes.
Excellent. Beyond staying informed, what else can we do?
Well, you can support companies and organizations that are working on perovskite technology, whether it's through investments advocacy or just spreading the word.
Right, and we can't forget the power of conversation. Talk to your friends, your family, your community leaders about the potential of perovskite. The more people understand and embrace this technology, the faster we can move towards that Solarpunk future.
It's about building a movement, a collective push towards a world powered by clean, abundant, and accessible energy.
And perovskite, with its potential for affordability, efficiency, and versatility, it could be a key player in that movement.
It's a technology that truly embodies the Solarpunk spirit, optimistic, innovative, and focused on creating a future that benefits both humanity and the planet.
It's a reminder that the future is not something that happens to us, it's something we create.
And with technologies like perovskite at our disposal, the possibilities are truly limitless. Imagine like skyscrapers that are just gleaming with energy-generating windows, or even cars with solar roofs that charge as you drive.
Yeah, it's like we're taking the idea of solar panels and turning it completely on its head instead of these big, bulky things we have now.
Right.
We're talking about seamless integration into our everyday lives.
Exactly. And it's not just about aesthetics either. Transparent solar cells could really open up access to clean energy in places where traditional solar panels just aren't practical.
I see that, yeah, like dense urban environments or even developing countries where space is limited.
Exactly. You could have entire communities generating energy from their windows and rooftops without sacrificing valuable space or aesthetics.
Wow. It's like perovskite is giving us this whole new toolkit to design our future and create a world where clean energy is truly woven into the fabric of our lives.
And it's a reminder that Solarpunk isn't just about the technology itself. It's about the way we think about energy and sustainability and how we use those tools to create a better world.
It's about that shift in mindset that's really at the heart of the Solarpunk movement. It's about believing that a brighter future is possible, and then using our creativity and ingenuity to make it happen.
Exactly. And perovskite, it's one of those technologies that really embodies that spirit of possibility. It's showing us that we don't have to settle for the limitations of the past. We can create a future that's powered by clean, abundant, and sustainable energy.
This has been such an eye-opening conversation, and it's got me thinking about all the other clean disruptions that are out there waiting to be discovered and developed.
Absolutely.
What other technologies are on the horizon that could help us achieve that solarpunk future we dream of?
That's a great question. And honestly, I think we're just scratching the surface when it comes to clean energy innovation. There's so much potential out there. And with the urgency of the climate crisis, there's never been a more important time to invest in these technologies.
It's exciting to think about what the future holds. And I'm hopeful that with technologies like perovskite, we can create a world where clean energy is the norm and not the exception.
I share that hope, and I think it's important to remember that we all have a role to play in making that happen. It's not just about scientists and engineers, it's about everyone coming together to demand a cleaner, more sustainable future and supporting the innovations that will get us there.
Absolutely, and that's what Solar Age is all about, inspiring our listeners to embrace that solarpunk spirit, to get involved and to help create the future they want to see.
Exactly. So for all our solar punks out there, we want to hear from you. What are your thoughts on perovskite technology? What other clean disruptions are you excited about?
Let us know in the comments. Share your ideas, your questions, your hopes and dreams for a solarpunk future. And together, let's continue building that brighter, more sustainable world.
Until next time, keep shining bright.
If you enjoyed this episode of The Solar Age, don't forget to like, subscribe, and hit the bell button so you won't miss any future episodes. We'd love to hear your thoughts. Drop a comment below about what resonated with you or share any ideas you'd like us to explore in upcoming episodes. Let's keep the conversation about a brighter future going.